right. So hello, everybody. My name is Flavio. We have a question. So the question here is, MapleSim looks like a 3D version of a 25-year-old Nastron-based tool working model, which was 2D and never got upgraded in the last 2 decades. Your ropes do not seem to be modeled in details as true catenaries. Your rollers don't seem to be able to swivel out of plane. Do you have the capability to have the box you support hit the ground and the slide with friction? Can you rope models real catenary with elongation that is not considered in the classical cable formulation? I believe this would be, yeah.
Yeah, I think.
I think this is you.
Yeah, I think I can jump in, as I am the one who has created the ropes and pulleys library. First thing first, that tool that you're talking about is one of my favorite tools of all time. It's a pity that it was discontinued. So we are actually not similar in that sense that the MapleSim is Modelica based. So a lot of things or everything in MapleSim is based on equations that we put together, including our multi-body. The answer to true catenary, the answer is yes, they are true catenaries in a sense that they're elastic, but they can form a catenary. Definitely, if you're interested to know more, contact us and I can show you how they would work. The pulleys will definitely swivel out of plane. So we have example in the library right now that in the tool, if you get to evaluate it, that show how that would work. So the tension that is applied by the connecting rope, chain, or cable to a pulley can be out of plane, and it will exert the right amount of torque, which moves the pulley to align with it. Obviously, there are some abstraction in the groove and how that would work, but for all intents and purposes, it is 3D. As for your other question regarding hitting the ground, so MapleSim does have a contact library or a sub-library within its multi-body, where you can attach primitives to your moving parts. So if you have a box, you can, for example, attach contacting points to its vertices and have it come into contact. So you can actually throw it on the ground and it will bounce and then come to a stop due to friction. So the answer to all of your questions is yes, and definitely we hope to show this in a demo. I'm reading your follow-up. Yeah, so that's the technicality. So a true catenary does not include elongation. So if you can be close to it. If the stiffness of the chain or cable is high enough that it's being close. So it's not in an academic sense of it, but for practical reasons, that's the case. Can you handle a cable disconnecting from a roller? No, we cannot. So these rollers, the disconnecting, the current formulation for the ropes and pulleys does not allow that. For that, you will have a variable structure formulation, which is something is not allowed by Modelica. But you can do some other forms, like I have worked on scenarios where you attach multiple spheres to the nodes on a chain. Then you can activate contact on those, and then you can have it contact with the environment. So some of that can be done, not just like you're mentioning, but it depends on what type of simulation you want to do and what tool would be the best to capture what you are requiring. For us, our equation-based heritage allows us to generate code and create efficient code for a lot of applications. But some of the application might be better suited for a game engine or physics engine base, which is not MapleSim. So it depends on what type of scenarios you're dealing with. We definitely are the best tool in a number of scenarios, but not all scenarios.
I see the question there about the possibility to work with several engineers on the same MapleSim project. I think, so the answer to that is we have when you install MapleSim, there's actually a diff tool that comes with it that you can access if you're just for yourself, doing a comparison of your model and you made some changes, you want to go back, or you have an old version of your model, you can always diff it and see what's changed. But we also have a version of a MapleSim model, which is, it's just a .zip file format. So it's a container. And we have a way that we can save it in an exploded version, essentially internally. And when you upload that into your Perforce set, or it doesn't be Perforce, whatever you're using for version control, you can save different portions of the model. So you make a change to one portion, that subsystem gets updated, but the rest of the model doesn't get changed. And so there's a ability to do a diff. We provide a tool, so you just hook that up to your version control system. It'll give you the same kind of diff. And it's nice, it's not just a textual diff, it gives you sort of the meaning behind it. You've changed the value of a parameter, it'll tell you, or you've changed the definition of a subsystem. The thing it doesn't provide today is a merge feature. So if you've got multiple engineers who have changed the same piece, there's no automated way to merge that in a version control tool today.
Maybe I'll just quickly jump in for another question, follow up to the questions that I got. So the formulation in the ropes and pulleys are based on linear stiffness. So if those type of ropes that you're referring to would not fit into linear formulation, then the answer would be no. But there's always, as we are in an environment that can be customized, there's always ways to look into extending what we have through custom components and include nonlinearities.
There's another follow-up in the end.
I am just reading it.
Okay.
One-year model of paper rolling looks 3D. Yeah, that is absolutely true. The web handling, as I mentioned in my session, was prior to this one, is only focuses on the planar systems. So the 3D is nice to look at, but it doesn't mean the system is 3D. The formulation assumes only machine direction, nothing in cross direction. Response to 3 suspension cable in 3 kilometer under. So the ropes and pulleys, it makes me feel like we should have done a session on ropes and pulleys. there is a recording on our YouTube channel on a webinar that I have done on ropes and pulleys. So if you contact us, or you can find it yourself, or you can contact us and we can send you that. So you can take a look at your on your own time, in your own time. But the chain and cable components, not the rope, but the chain and cable components, they do have an option to activate wind, and then they follow the well-known formulation for the drag and lift coefficients. You can also override that and use your own table-based coefficient for lift and drag based on the angle of attack, or you can use the well-known formula, and then you can apply wind and see the effect of that on your system. Icing, no, but wind profile, yes, and the ground profile. So you can have things placed at different places in your model, and you can move them around. But again, if you have wanted to have a long, complex cable coming to contact with an arbitrary shape, that might not be the best use case for MapleSim. For simpler cases, as I said, you can distribute spheres with the same radius as your chain and have emulate in a limited form that way. But for a very detailed modeling, a game engine based approach would be more appropriate. The last one, hopefully I didn't miss anything. So do you have ability to load the cable with its own gravity loads? Absolutely. And then there is another one. So I think that might be distributed loading. So extra load on the cable can be done in a discrete form. there is no option right now to add a load density based on linear density on it. Not sure about WX, WY, WZ, but if it's distributed loading, right now you can add extra load on a chain or cable via distributed on the nodes that you have decided to discretize the rope. And maybe, so I guess no comment on the last point from you, Andreas, aside from congratulations.
All right, there's a question from Alex. Oh, we have okay. There's a question from Alex now. What are the types of applications where system level modeling uses MapleSim components is a better fit than full FEA modeling? Would it work well for systems with multiple engineering domains? The answer is absolutely yes. With MapleSim, you can model multiple domains. It is a multi-domain system level modeling environment where you can combine the interactions between different domains together in one single environment and build models quite efficiently. But of course, it is in terms of FEA, the time it takes to build the model, that becomes much more tedious in process. So that's when system level modeling becomes quite advantageous to work with.
To the question of running FEA with a MapleSim model, there are different ways that you can do that. Different tools, depending on the FEA system. Sometimes they'll provide essentially a surface model that they'll export as an FMU or something like that would run inside of MapleSim. So we would import that as an FMU, and then it would just be part of the simulation that we do. So you can incorporate all the other domains and sort of get all the advantages of running it inside of MapleSim. You can, there are some ways of doing it live depending on the FEA tool. But again, the usual way that we connect with FEA systems is via the FMU export. So that's sort of the interface we use between the two. Either they'd import ours or we'd import some variation of what they're kicking out and bring in our tool for simulation. The tricky part is often what happens on the boundaries of those connections, which I mean is handled through the FMI or the FMU ports. Right, so this is a question about block sizes. There's a question about working with vehicle dynamics, difficulty debugging errors for block size, block dependencies, and initialization. I'm not sure if you're referring perhaps to the, well, there's the output inside the console, but there's also an initialization app that allows you to walk through. The block structure really is saying, we've analyzed the equations and we've organized them into groups of equations that need to be solved simultaneously. And then their results give you sort of the next block. So they depend on the previous blocks. So if I have a block A, it might have equations 1 and 2 in it. The results of the variables 1 and 2, I need to define the values for variables 1 and 2 before I can solve block B. They're used inside there. And so we break it into blocks because, I mean, we could just say, well, it's just one giant system and we're going to solve that, but that's very expensive to do numerically. So what we do for initialization is try and break those blocks into as small independent groups as possible. And so what you'll see is if you go to the initialization app, if you select a given block, it'll tell you what variables the initialization of that set of variables is dependent upon. And if there's something there that doesn't look right, you can actually trace back to say, okay, which block did that variable get solved in? And can I track down where my errant initial conditions are coming from? There's no published research paper on how we use that portion, although the initialization really, it's just creating what we consider a Tarzan block structure. For solving a set of equations. And we use 2 independent structures, one for initialization and one for simulation. And the reason we use 2 independent structures is that given the initial conditions you may have specified, we might want to group things differently because there's different knowns than would be required when you're actually doing the simulation.
It's interesting that we got another question regarding the ropes and pulleys. I mean, Arecibo telescope. Anybody who is interested in engineering was, I'm sure, devastated by that collapse. So immediately after seeing the news and watching the videos, I created one for myself. So Swati, I can quickly share that on the
Sure.
screen.
Yeah.
It's not an official model, but since it was asked, let me just see if I can put it on the screen. It's better than just saying yes. Share my screen. Share this one. Should be a VLC player on the screen. Is that correct?
Yep.
So here goes nothing. Let's see. Okay. Yeah, this wasn't a truly validated model. It's just something that I wanted to put together and kind of play with the scenarios. We do have a component in the MapleSim that allows for detaching, so you can basically emulate that scenarios. Like it might not be a recreation of what actually happened. It's just looking into what is going on. Just like in reality, they didn't all snap at the same time, and then there are other stuff happens at this point, which is outside of the scope of maybe MapleSim or my modeling capabilities. So just wanted to show you because this was a was an interesting direct question. So there you go. I have another question. Is it possible to discretize a CAD model in Maple? So I mean, discretize could mean different things. One meaning could be to kind of mesh that, like a volumetric mesh. So the answer would be no, at least not out of the box, as in Maple does not have an FEA package inside it, or no one has created one yet. So the answer to that question is unfortunately no.
Yeah, if the question is about a beam, again, we're not discretizing CAD general shapes, but there is a flexible for specifically for beams inside, but that's an analytic formulation inside of MapleSim. Yes, just to say it's the question about meshing is one that we've chatted about, and at different times we've talked about adding it to the CAD toolbox as something that we would sort of have an internal meshing and bring something in. The problem one of the problems we always chat about is that generally when people are doing meshing, they have their favorite tool or their way of doing it, and we've gone back and forth whether it's enough to do sort of an internal meshing for someone to get a basic answer to the CAD that they're bringing in, or whether they're going to want a very specific meshing that they've got more control over it, at which point you're maybe wanting to grab that from your CAD tool directly. So certainly something that gets talked about here, but as Orang pointed out, there's no meshing in the product today. So there's a question here about the best way to debug inconsistent system error. One of the most challenging things. So MapleSim does a lot of fantastic things when it comes to starting from the initial set of equations that you have. And there's a lot of great symbolics at work to simplify that into the actual causalized simulation procedure that you end up simulating. However, in that process, it is when an error like inconsistent system comes up, what you really want back is something that gives you an engineering answer, something that says, hey, you needed to have some compliance here, or something like that. So for an inconsistent system error, generally that refers to the fact that there's, an initial condition or two initial conditions that are assigned that are in conflict with one another, or you've got, you can think of a multi-body system where you've defined frames that are attached and the mechanism can't actually assemble the way that it's been specified. because if you were to make a loop, the loop doesn't have the same endpoints. It ends up being offset. So often in a model like that, the other AEs can sort of suggest their approaches and tactics, but I often try to break down the model into the pieces, and just sort of isolate portions and verify and then move up. One thing, one trap that people sometimes fall into is they just start building and building and building and don't simulate as they go or don't check things. And then you end up with a very large model, you run it, you get some kind of an error. And I should say, Hattie, this is not what I'm suggesting for that has happened here. But it goes to the idea that you build up your system and you test it as you go. And on the flip side, from our product side, we are working on giving, when there's patterns to some of the errors that come out, to giving more engineering type answers that can help you sort of diagnose it faster than just here's what's mathematically wrong with the system that we're trying to analyze. So it was you're fair when you said it's a bit of a general question, but it's also fair to say that sometimes the error messages are somewhat general as well.
There was a question regarding the type of CAD tools that we can support with our CAD import. I think we put the answer directly into the chat, and I believe everybody can see that. According almost every major format is supported with our CAD toolbox.
The question about why do we not have a toolbox for aerospace applications? Yeah, fair question. MapleSim at its core, most of the core libraries that come with it are actually pretty general. Can you do aerospace applications? Yes. But if you're doing aerospace, probably there's a set of standard either components or sort of composite components that you're going to be using or applications you're going to be using. And to date, we've not built a toolbox like that. Some of it has to do with sort of sets of expertise we have in-house. And some of it just has to do with, there's lots of toolboxes that we're like, oh, we should build this one too. And it's just prioritizing which ones get first, get first product resource times.
Well, it doesn't qualify really as aerospace, but we have been part of a very important research with a big research group on high altitude kites, if that counts.
That's right. But although there's still not a kite toolbox in that regard.
Well, not publicly.
Fair. That's the other issue with toolboxes sometimes, is that we'll work on these kinds of projects with customers, but I mean the work is either IP connected to the project or it's in a project state and it has to be taken sort of to the next level to make it just a general library. Question there about connecting MapleFlow with SIM, and I'm sad Samir's not here on this one. Actually, one of the things I get to make the roadmap discussions, I guess. One of the things we're hoping to do is actually put Flow into SIM, similar to how you can pull up a worksheet today inside of MapleSim. The hope would be, or the plan is, to be able to pull up sort of a scratch pad of MapleFlow, and that would be able to interact with MapleSim in much the same way that Maple does, only it would have all the interface features that SIM has, or that Flow has. To the extent that Flow can call out to the Maple engine, and the Maple engine has access to MapleSim, there is an ability to make a connection, but there's not an explicit one right now between the two tools.
So I do see there's an anonymous question about if there's a way to review any of the missed presentations. And Rochelle, correct me if I'm wrong, but I believe they will be available at some point. Maybe you have some more details on that?
Yeah, I was literally just unmuting my microphone when you popped in. Yes, we will have recordings available afterwards. Everyone who registered today and attended a session will receive a copy of, or at least a link to all of the recordings from today's sessions when they're available. Okay, so it looks like we may be coming to the end here. We've gone slightly over time. So any last minute questions you guys want to address or comments or anything like that?
I, for one, thanks for the lively session.
Yeah, and also just in addition to some of the questions, there were some suggestions, which are always useful feedback to hear. So thank you for those as well. And we will continue to try and get more physics-based errors. As well as putting flow into sim. These are all good things.
Okay, well, with that, I think it's time to officially close our online engineering roadshow. Thank you everyone who attended. Thank you to all our presenters. This has been a great day. This was a particularly lively discussion, as Arang said. So thank you so much for joining, and we'll see you again soon.
Thank you, everyone. Take care.
Right, thanks.
Thank you.